Hello, welcome back. We are now at prestress loss. In pre-stressed concrete applications, most important variable is the pre-stress. Remember na sa previous video, yung pre-stress concrete is basically two methods. Merong pre-tensioning tsaka post-tensioning. Okay, so itong pre-stress na yan yung process na kino-compress yung concrete. Pre-stress does not remain constant. It is reducing. It reduces with time. Even during pre-stressing of tendons and transfer of pre-stress, there is a drop of pre-stress from the initially applied stress. So, yung mga bakal niyan, yung tendons niyan, parang goma, parang rubber, lastiko. Habang tumatagal, nababawasan siya ng properties. So, parang nawawalan siya ng lakas. Reduction of pre-stress is nothing but the loss in pre-stress. Early attempts to produce pre-stressed concrete was not successful due to loss of pre-stress transferred to concrete after few years. So, remember the word few years. So, meron tayong time-dependent losses. Pre-stress loss is nothing but the reduction of initial applied pre-stress to an effective value. Itong initial applied pre-stress, ito yung pressure na nakukuha dun sa jacking equipment. No? Yan yung equipment na hinihila yung tendons. In other words, loss in pre-stress is the difference between initial pre-stress and the effective pre-stress that remains in a member. And then, itong effective pre-stress, yan yung stress na naiiwan dun sa tendons after tinanggal yung pre-stressing equipment and after inilagay yung lock. Loss of pre-stress is a great concern since it affects the strength of member and also significantly affects the member's serviceability, including stresses in concrete, cracking, camber, and deflection. Now, when you talk about serviceability, ito na yung terms of comfort. For example, ayaw natin ng beam na malaki ang deflection, although it is safe. Ayaw din natin ng beam na may visible cracks, although it is still structurally safe. Okay? Yan ang tawag na serviceability. And then loss of pre-stress is classified into two types. We have short-term or immediate and long-term or time-dependent losses. Short-term, this is immediate losses occur during pre-stressing of tendons and transfer of pre-stress to concrete member. Okay, and then long-term, time-dependent losses occur during service life of structure. Immediate losses includes elastic shortening, slip at anchorage, and then friction between tendon and tendon duct, and wobble effect. And then we have creep and shrinkage and relaxation of pre-stressing steel. So, ito siya. You have immediate, time-dependent, divided it into two. And then, sosolvin natin lahat yan isa-isa. Losses in various pre-stressing systems. Remember na meron tayong pre-tensioning and then post-tensioning. Pre-tensioning, ito, hinihila na kaagad yung tendons and then bubuhusan siya ng semento. Okay? And then, pag tumigas na yung semento, doon pa lang ikakat yung tendons. Samantalang sa post-tensioning, wala pang stress yung tendons. Okay? So, mga duct pa lang o kaya yung mga tube ang nakalagay doon. And then, bubuhusan ng concrete. And then, kapag tumigas na yung concrete, dun pa lang i-insert yung tendon at hihilain. Kaya mapapansin ninyo dito sa pre-tensioning, walang anchorage slip, walang friction loss. Dahil, nag-band na yung tendon doon sa concrete. And then, sa post-tensioning, meron siyang anchorage tsaka friction loss. So, yung ating magiging sample, dito tayo sa post-tensioning. Besides, karamihan ng practice dito sa post-tensioning. So, elastic shortening in pre-tensioned concrete, when the pre-stress is transferred to concrete, the member shortens and the pre-stressing steel also shortens it. Hence, there is loss of pre-stress. So, ito yung part na kapag yung concrete nag-harden na, and then in-apply mo yung pressure, tapos kinat mo yung tendons, ibig sabihin, iniipit na nung tendons yung concrete, nag-decrease yung size or yung length nung concrete. So, ito yung tinatawag na elastic shortening. In case of post-tensioning, if all the cables are tensioned simultaneously, there is no loss since the applied stress is recorded after the elastic shortening has completely occurred. If the cables are tensioned sequentially, there is loss in a tendon during subsequent stretching of other tendons. So, dito tayo sa sequential tensioning. Ibig sabihin, hindi sabay-sabay na tinetensyon yung tendons. Okay? So, merong pattern yan. Loss of pre-stress mainly depends on modular ratio and average stress in concrete at the level of steel. Loss due to elastic shortening is quantified by drop in pre-stress in a tendon due to change in strain in tendon. The change in strain in tendon is equal to the strain in concrete at the level of tendon due to pre-stressing force. This assumption is due to strain compatibility between concrete and steel. So, strain compatibility between concrete and steel, ito yung strain diagram, So, remember na yung concrete is 0.003 ang kanyang strain, tapos sa steel naman, strain Y. So, habang tumataas ang load, tumataas din ang strain ng concrete, ganun din tumataas din ang strain ng steel. And the diagram is linear. Okay, so ibig sabihin, yun yung strain compatibility. Strain in concrete at the level of tendon is calculated from the stress in concrete at the same level due to pre-stressing force. Loss due to elastic shortening is quantified by the drop in pre-stress in the tendon due to strain in tendon. Change in strain in tendon is equal to strain in concrete at the level of tendon due to pre-stressing force, which is called strain compatibility between concrete and steel. Strain in concrete at the level of tendon is calculated from the stress in concrete at the same level due to the pre-stressing force. A linear elastic relationship is used to calculate the strain from the stress. Pre-tensioned members, when tendons are cut and the pre-stressing force is transferred to the member, concrete undergoes immediate shortening due to pre-stress. Immediate shortening. Tendon also shortens by same amount, which leads to the loss of pre-stress. Post-tensioned members. If there is only one tendon, there is no loss because the applied pre-stress is recorded after the elastic shortening of the member. And then for more than one tendon, if the tendons are stretched sequentially, there is loss in a tendon during subsequent stretching of the other tendons. So, ito yung diagram. So, imaginein mo na ito yung strand, and then ito yung concrete na matigas na. This is this is pre-tension. So, binuhusan yan ng concrete. And then, mapapansin mo na flat yan. Yung horizontal line na yan, ano? And then, while this is horizontal, hindi pa nakakat itong brown line na yan, tendon. Ibig sabihin, relax pa lang, no? And then, this is supposed to be a movie, animation eh. And then, once na nakat na yung tendon, mag-decrease itong length ng concrete. Ang tawag dun ay elastic shortening. So, pati yung length ng pre-stressing tendons magdi-decrease din. Okay? And then, notice na ito, yung strand nasa ilalim nung gitna nung beam. Kaya mapapansin nyo na yung kanyang deflection is upwards. Dito naman, so yung kanyang tendon somewhere in the middle, okay? And then we now go to linear elastic relationship is used to calculate the strain from the stress. Sa sample natin later, meron tayong gagamiting equations for elastic shortening. Now let's go to anchorage slip. In most post-tensioning systems, when the tendon force is transferred from the jack to the anchorage ends, the friction wedges slip over a small distance. So, anchoring ends. So, yung anchor, yan yung mechanism or lock para yung tendons will remain stretched in the concrete. Tapos, yan ang maglalak para matanggal mo na rin yung jacking equipment. Anchorage block also moves before it settles on concrete. Loss of pre-stress is due to the consequent reduction in the length of the tendon. Certain quantity of pre-stress is released due to this slip of wire through the anchorages. Amount of slip depends on type of wedge and stress in the wire. Kaya, yung jacking force, bago nila ikinakat, medyo tinataasan nila yung jacking force. Dahil, kapag kinat mo na yon, meron tayong mga losses. The magnitude of slip can be known from the tests or from the patents of the anchorage system. So, bawat manufacturer ng tendon tsaka yung anchor, meron silang mga specifications na losses na nilalagay. Loss of stress is caused by a definite total amount of shortening. Percentage loss is higher for shorter members. Due to setting of anchorage block, the tendons shortens. There develops a reverse friction. Effect of anchorage slip is present up to a certain length called the setting length. Anchorage loss can be accounted for at the site by overextending the tendon during pre-stressing operation by the amount of draw-in before anchorage. And then later on, meron tayong computation ng anchorage slip. Frictional loss. In post-tension members, tendons are housed in ducts or sheath. So, yung ducts or sheaths, yan yung mga parang tube na nasa loob ng concrete. Ito rin yung nilalagay bago buhusan ng concrete. Dito dadaan yung mga tendons. And then, after jacking, tapos after nag-harden na yung concrete, etong mga duct na yan, nilalagyan yan ng grout. If the profile of cable is linear, the loss will be due to straightening or stretching of the cables called wobble effect. So yung wobble effect, mako-consider mo yan kapag yung cable or yung duct ay parabolic. If the profile is curved, there will be loss in stress due to friction between tendon and the duct or between the tendons themselves. Post-tension members, this is now friction. Friction is generated due to curvature of tendon and vertical component of the pre-stressing force. Then this is also a figure. The magnitude of pre-stressing force, Px at any distance, x from the tensioning end follows an exponential function of the type, this type. We will also be having an example of this sa mamaya, later on. And then we have time-dependent losses. So ito na yung mga losses after years of service. We have creep of concrete. Time-dependent increase of deformation under sustained load due to creep. The pre-stressed tendons decrease with time. So factors affecting creep and shrinkage of concrete. You have age, applied stress level, density of concrete, cement content in concrete, water-cement ratio, relative humidity, and temperature. For stress in concrete, less than 1/3 of the characteristic strength, the ultimate creep strain is found to be proportional to the elastic strain. Curing the concrete adequately and delaying the application of load provide long-term benefits with regards to durability, loss of pre-stress, and deflection. In special situations, detailed calculations may be necessary to monitor creep strain with time. For shrinkage of concrete, time-dependent strain measured in an unloaded and unrestrained specimen. Constant temperature, we have loss of pre-stress due to shrinkage is as follows. We will also be having this computation in our sample. And then we have relaxation. It is the reduction in stress with time at constant strain. Decrease in the stress is due to the fact that some of the initial elastic strain is transformed into inelastic strain under constant strain. Stress decreases according to the remaining elastic strain. We have factors affecting relaxation. We have time, initial stress, temperature, and type of steel. Relaxation loss can be calculated according to this. And then losses in pre-stress, meron tayong mga sosolvin na geometric properties. So we have basic and then the transform section properties. And then dito, CGC, this is the center of gravity of concrete. And then CGS, center of gravity of the steel. So dito tayo sa types 1 to 6. And this figure is type 1 to 4. Mas malaki yung ilalim. We have here the figure for elastic shortening. So this is the original length of member at transfer of pre-stress. Ayan. And then after some time, nag-reduce yung section, yung length, ano? And then creep of concrete is defined as the increase in deformation with time under constant load. Due to the creep of concrete, the pre-stress in the tendon is reduced with time. Shrinkage of concrete is defined as the contraction due to loss of moisture. Due to the shrinkage of concrete, the pre-stress in the tendon is reduced with time. Relaxation of steel is defined as the decrease in stress with time under constant strain. Due to the relaxation of steel, the pre-stress in the tendon is reduced with time. The losses of pre-stress due to creep and shrinkage of concrete and the relaxation of steel are all time-dependent and interrelated to each other. In pre-tensioning system, tendons are first tensioned between rigid anchor blocks cast in the ground. Concrete is subsequently placed and compacted to the required shape and size. Pre-tensioning methods rely on the bond developed between steel and the surrounding concrete. The tendons should be fully bonded over its entire length. After the concrete hardens, the tendons are released from the pre-tensioning bed and the pre-stress is transferred to the concrete. For post-tensioning, concrete units are first cast by incorporating ducts or grooves to house the tendons. When concrete attains sufficient strength, the high tensile wires are tensioned by means of a jack bearing on the end face of the member, and the wires are anchored by wedges or nuts. The forces are transmitted to concrete by means of the end anchorages and also when the cable is curved through the radial pressure between the cable and the duct. The space between the tendons and the duct is generally grouted after the tensioning operation.